you have to find impedance at first step. And when you consider impedance determination,
Yes, sir.
how many impedance you may have? Impedance category?
The three impedances:
Three impedance, Z0, Z1 and Z2.
Z0, Z1, Z2.
Right. And when you want to find that impedance, that means you have all the sequence impedance in your hand. And that impedance, first step calculation, can be done by two methods. The method which we have mentioned in last class, it was based on Thevenin equivalent circuit. Today, we will try to discuss another method which is based on bus building algorithm outcome. You may recall the bus building algorithm when we want to determine Z bus. What was the step to determine Z bus? Bus building by the bus building algorithm. From where we can start the journey to determine Z bus, which types of diagram we need.
The single line diagram.
We can start that from single line diagram as well as from impedance diagram. Okay, that means when you put the data, impedance diagram. So impedance diagram is the base to determine Z bus. So impedance diagram information, you have to collect individual impedance or branch or link to generate your total impedance of Z bus matrix. That means impedance matrix will be generated. From this Z bus 1, what does it indicate?
The positive sequence.
Z in terms of positive sequence, right? And it is in terms of bus building outcome. Okay, by this time. This is the positive sequence bus impedance matrix. Because Z bus 1. This is zero sequence bus building algorithm outcome because 0. And these are actually determine the result or outcome. Okay, outcome means you have been given the final result for that Z bus in terms of the sequence component. And another thing you have to be careful that Z bus 1 and Z bus 0 will be different, but Z bus 2 is same as Z bus 1. Okay. So we can use or we can make equivalent of Z bus 1 to Z bus 2. Okay. But Z bus 0 will be different. And you know how to determine
Z bus, sir. How do we make them, sir?
Yes, that's the question. That how can you get that outcome, right? Z bus 1 or Z bus 0.
Yes.
If you can recall what was the Z bus determination, right? The regular Z bus, not 1 or 0. How you can generate Z bus regular from the impedance diagram? The last quiz you have attended based on Z bus, right?
Sir, the অনেকগুলো method.
Method লাগবে না. You have to.
Yes, sir. We do that iteration, sir. With
consider the frame that what you have to apply. You have to step. What are the necessary steps to determine Z bus? First step is to consider the branch link concept, right? Then you can generate the rule, different rule for different branch or link, so that you can generate your final Z bus. So if you can recall, what will be the size of the Z bus? How many bus will be there? Z bus 1. From this matrix, can you say?
3 bus.
There should be 3 bus, right? Because of the size of that Z bus. Because it is 3 by 3 matrix. So 3 by 3 matrix means the regular Z bus will be based on 3 bus. Okay. And another thing, how can you generate that Z bus? This is actually the continuation of last class lecture. There it was 3 bus system. If we can go back to that discussion. Okay, that was the that was your regular single line diagram, right?
Yes, sir.
Yes,
Or
sir.
that single line diagram has the Z bus possibility based on that single line information. And here you can see you have 3 bus there, right? And in between them you have the interconnection. Actually, ground will be there from ground to 2, ground to 1 and 3. So you can determine Z bus from that single line diagram based on your earlier concept. Like you have this reactance information and number 1 node, and this is the ground, number 2 node and ground, and this is 3, right? So you can use those branch link concept to get the final outcome of this Z bus in terms of positive sequence. That means that will be Z bus 1. Okay. Likewise, you can generate Z bus 0 from this diagram. Okay, and when you generate your Z bus 0, the result is given now. Z bus 1 and 2 is actually same. That's why you don't need to find repeatedly. You can reuse that information. So it is the result or outcome of that Z bus. Okay. That means Z bus 1 and Z bus 0. And Z bus 1 and 2 is same. They have the same reactance information for both the scenario, positive and negative. Now, when we have that Z bus, instead of Thevenin equivalent, we have generated that Z bus from three rule concept, right? That means you have been given reactance diagram or single line diagram, and you can generate your sequence, that means bus impedance matrix for different sequence. Is it clear?
So can you repeat, sir?
You have been given single line diagram, and from that single line diagram you can find or determine your Z bus based on 3 rule.
The quiz that we gave, sir, that
Yes,
quiz.
the quiz I have given you. Based on that concept, you can find Z bus 1 for positive sequence reactance diagram, Z bus 0 for 0 sequence reactance diagram. Okay, and those diagrams are different. That's why your Z bus is different.
Okay, স্যার তাহলে স্যার ওটা একটা ম্যাচ করতে আমাদের 2 দিন সময় লাগতো, অনেক সময় লাগতো। এখন স্যার এই দুটো ম্যাচ যদি আমি সলভ করি,
is already given. Actually, you have to apply or you have to know the earlier step. Okay, Z bus determination is one step, and if it is fault calculation, that outcome will be given. You can use the outcome direct without making the calculation, because in this case or in this time, your main objective is to find the fault. You don't need to show your expertise to determine those Z bus now for this problem. Okay, you know how to.
That's a 25 marks question itself.
Yes.
Yes, sir.
You know how to find that Z bus from earlier step. If you are asked to generate Z bus, that may be one question. Okay, but when you are asked to generate or determine fault current, in that case, if you are generating Z bus, that will be your other step. That means it will start from that. You don't need to start from that step. Z bus will be given. You have to deal with the fault current scenario then. But if it is asked to find only Z bus, in that case you have to apply the general rule. That means what is asked there, you have to check the question first. So you know how to find that Z bus. This time it is the result you have to utilize, but you know how to determine that. Second one, when you have actually Z bus, from the impedance diagram, you have actually two paths. One option is you can find the fault current from regular equivalent circuit calculation. That means using your regular Thevenin concept, you can find Z0, Z1, Z2, right? From single line diagram or reactance diagram, you have two alternative paths. One in regular Thevenin equivalent concept to determine your regular Z0, Z1, Z2. Another path is the bus building algorithm concept to generate Z bus 0, 1, and 2. Have you got my idea? That you have two different methodology to reach your Z bus 0, 1, or 2. Okay. Z0, 1, 2 has two different paths. So when you are following the Thevenin concept, you don't need to make the calculation of bus building and vice versa. That means for this case, as you are determining Z bus based on bus building algorithm, you don't need to apply the Thevenin concept for this case. Now you may ask, which methodology is better or superior, right? That may strike your mind that you have two alternative way to reach Z bus Z0, 1, 2. Which methodology you want to apply? Actually, that will be based on your scenario. If it is a small arrangement, say for example 3 bus system or 4 bus system, you can use either Z bus or Thevenin. Okay. But when it is more than 3 or 4, like 10 bus system, it will be quite difficult for you to determine regular Z012 by Thevenin concept. In that case, the Z bus building algorithm will be helpful for you. Okay. So you have to know two way. If the circuit is simple, you can apply your Thevenin concept like up to 4 bus network. But when it is more than that, you have to apply the second option like Z bus building algorithm concept. If it is 10 bus system, it may be more than 10, it may be 100 bus system. In practical case, it might be more than 100, right? The complex power system. So your Z bus size will be accordingly. That means if you have 100 bus arrangement, your Z bus array will be 100 by 100. And in that case, that Z bus in terms of Thevenin equivalent concept, it will be quite difficult. So now our main concern, the fault calculation based on Z bus. If you can recall balanced fault scenario which is three-phase fault, as it was mentioned, third bus was the fault bus. That's why it is I3012. Okay. If it is bus 2, in that case, it will be I2012. Fault, in which bus it was the fault? It was in bus 3. That's why your calculation or the system equation will be based on bus 3. And here you can see Z331, that is the bus 3 fault impedance in terms of positive sequence, and ZF. Okay, so only positive sequence current information will be there, the other will be zero sequence and negative sequence.
Sir.
Yes.
So one small question, sir. We are finding the
fault current.
Positive sequence or add value.
Yes.
Yes. Because the fault is in, why do we only find this value, sir? অন্যগুলো zero কেন?
This part is actually, if you can recall that your fault or the sequence component information, you have only positive sequence circuit at the source, right? You will not have negative and zero sequence source. That's why you have the positive sequence part as the option. Okay. And Z331, that is actually from where you can get that. Z331, that is from that matrix. Z1 and Z33, this one, right? This is the Z33 position.
Yes, sir.
And it is from Z1 bus. That's why it is Z331, 0.22. Okay,
Yes.
0.22 is there from the bus. And ZF, it's already mentioned fault impedance 0.1. So you can use those two to get that information. It is in terms of 0, 1, 2 domain. Whenever you make the calculation, actually you have the impedance in 0, 1, 2 domain. That's why your current should be in also 0, 1, 2 domain in first step. But our target is to generate that fault current in ABC domain. That's why you have to consider that A operator multiplication to get that information of 0, 1, 2 domain to ABC domain. Okay. So fault current now is in your hand, which is ABC domain, and fault bus is at 3. That's why I3 ABC. During fault F.
Yes, sir.
So we have balanced scenario fault current at bus 3 for ABC sequence. Always you have to find that first step in 0, 1, 2 domain, because 0, 1, 2 Z. Z is in 0, 1, 2. That's why your current is in 0, 1, 2. Okay. And your final or ultimate target is to generate its equivalent in ABC. Likewise, when you have fault current for bus 3, you can now find the voltage at different bus. Like you have 3 bus, you have already mentioned from the matrix size, you can say it is actually 3 bus system. So you have to now find or determine all the bus voltage during fault. Okay. And that can be found based on this formula V1F 1 minus Z13 I3F. That I3F is actually this value or that information, the fault impedance information. So I3 Z13, regarding that Z13, we know from that matrix Z131. Let's check. Z13 position will be 1, 1, 1, 2, 1, 3. This one, right? Z13. Is it okay?
Yes.
Z13 or this one is Z13. That will be actually same. Z13, this one, right? This is Z31.
No, sir. RC, sir. R. So
this
1 is the row number. Yes.
This one should be right. So
column is
0.13, it will be Z131. So Z131 is there and I3F is there. So we can use those information to determine V1F. That means fault bus voltage, bus number 1 voltage at during fault. Likewise, we can find bus 2 voltage during fault based on 2, 3 information, Z231. Okay, let's check Z23. This is Z1 and Z23 will be this one, right? So Z23 is 0.12. Z23 and your I3F is already there, you can use that. And Z33, what will be the Z33 value in terms of bus 1 matrix or Z bus 1? This is Z33, right? So you can put those information to find all the bus voltage V1F, V2F, V3F during fault. Okay. Now, as you have fault current calculation completed for bus 3 and fault voltage for all the bus, can you find fault current for line? Fault current between line, how can you find that? Do you have any clue? How can you find fault current in line?
So a line as if like through ZF,
Yes.
does that mean the current through ZF?
ZF, not. Fault current in line means you have 3 line possibility between different bus. As you have 3 bus, they are interconnected line, right? What about the line current
Yes, sir.
information during fault? Because line current will not be same like the normal situation, right? Due to fault path, your regular current will be deviated. So what you have to find the line current, how can you find line current? As you have fault voltage for different bus. Say for example, we want to find line current of I12. How can we find that? Between bus 1 and 2, what will be the line current? V1F minus V2F over Z12, the impedance of the line, right? Is it okay?
Yes, sir.
So if it is okay, then we can find the line current. Let's see, this one is the line current between 1 and 2 bus during fault, which is actually 2 1 direction. That's why 2 minus V1F. These are the two information, V2F and V1F. And the impedance, this is Z in a small letter, right? That means your impedance information, not the matrix information. And what about Z121? From where we can get that? Z121? It will not be from
Positive
the
sequence diagram, sir.
It will be from diagram, right? Z121 for positive sequence diagram, you have to put the value. Okay. That information for the line between bus 1 and bus 2, the impedance information. Let's check what was the single line diagram because I cannot recall. For positive sequence network. That one was the line information, right? The impedance information between line 1 and 2 for positive sequence. Okay. So from this diagram information, the impedance information, as we have V1F, V2F, and we have the impedance Z12 in terms of 1, that means positive sequence network. And we can put that information to get the line current during fault I12, I12F. Okay. And in the same way,
I have a small question, sir.
Bolo.
So why did we make this right side diagram, the diagram B? What was the purpose of this?
This one?
Yes, sir.
It is
Yes,
actually the conversion for equivalent circuit or equivalent impedance determination. Because our object was to get the equivalent impedance across bus 3. Because bus 3 has the fault, so we have to determine bus 3 equivalent, Thevenin equivalent impedance. And to do that, we have the circuit, and that circuit has some delta. If we have delta, we cannot find the equivalent impedance simply. We have to shift that delta to Y. That is the equivalent of delta network.
Yes, sir.
Okay, to get that in terms of impedance calculation for the Thevenin circuit across bus 3. That's why you have to shift that delta regular single line diagram to equivalent Y network from delta Y conversion. Okay. To generate your impedance, equivalent impedance across bus 3, which is the fault bus, based on Thevenin equivalent concept. Okay, that's why you have to switch that light diagram from that given single line diagram. So if you are asked to find Z13, you can also find that right now, because you have the impedance information, and V1F you have determined already, V3F is in your hand already. So you can put that information to find the line current between 1 and 3 node during fault. Okay. So let's move to our problem, which we were. Okay. So I13F, Z13, this is 0.15. So we can use those information for line current between node 1, 3 during fault. Okay. In this way, we can find the fault current. Now, if you have this problem, that means that part is done based on balanced fault scenario or three-phase fault scenario, right? So balanced fault, you can do the calculation. Can you recall or what we have discussed for balanced fault step? First part, what you have done?
Sir, find the Thevenin equivalent impedance.
No, Thevenin equivalent impedance was other approach. Thevenin equivalent impedance has different path to generate your I3.
Yes, sir.
Fault current.
Yes.
But here you have used I3 from Z bus. Okay.
Oh, yes, sir. Yes, sir. Yes, sir.
This is the Z bus Z331. This is not the Thevenin equivalent circuit. This is other approach based on Z bus. Actually, this approach is simpler than the
why do we need this approach? Because simpler.
Because
Yes, sir.
the
Simpler.
network size, because it is the network size which is responsible to shift that idea to Z bus concept. Like the regular Z bus, why you need regular Z bus? You know how to find Z bus from inspection method, right? Why should you apply Z bus? That's the first question. Then you can answer, get that answer for this part also. When we apply bus building algorithm, why we have applied that bus building algorithm? We can find that by inspection method, right? So why we have applied bus building algorithm using those 3 rule concept?
So that we can handle a lot of buses together, a large number of buses.
Large number of bus calculation will be easier or simpler, because by inspection method it will be difficult for you. Likewise, short circuit or fault current calculation, if you apply Thevenin concept, you can do that, but it is up. It has some limitation. That means up to certain limit you can do that by Thevenin concept or equivalent circuit. But when you move for large circuit, it will be easier to shift that idea to bus building concept. Okay, Z bus. From Z bus you can find the fault current. It will be more convenient. Okay. Without solving your Thevenin circuit. Here you can see it is Z331, it is already 0.22 from that bus matrix, right? But this Z331 is determined by earlier concept Thevenin circuit solution. After Thevenin circuit solution, you can get that result or get that value, right? But now, as you have this information in your hand already, you can just collect the data, necessary data from that matrix based on your requirement. So you don't need to make the calculation like Thevenin equivalent. Though these values are same, 0.22 was also for Thevenin equivalent impedance in terms of sequence network of positive 1. For this case, it is also same, but here it is already given. If it is not given, you can also determine that, right? If, say for example, it is not given, but in exam it will be given. But if somehow, if it is not given, you can apply your 3 rule concept to generate that matrix, right?
Yes, so just for delta Z, Z transpose, ওইগুলো দিয়ে.
Yes, the Z transpose and rule 3, those are the different rule you have to apply to generate your Z bus. Okay, so you know now actually they are interrelated. From the very beginning of this course, now you can understand the philosophy of the course. We have started our journey from per unit calculation. Then we have moved from different diagram like reactance diagram, admittance diagram, impedance diagram. And now you are in a state to solve the fault current based on Z bus, right? So they are different layer actually. You cannot omit the earlier layer to solve this short circuit current concept. Okay, so they are interrelated.
Yes, sir.
And that's the actually interesting part of this course, that all the topics are discussed, or when you can solve that short circuit current based on this philosophy, you know the total course picture. That in a single problem, starting from a single line diagram, you can solve that for bus Z bus. Then you can apply the fault effect on that Z bus and solve the fault current or other bus voltage or line current from there, right?
Yes, sir.
Okay, so these are the actually idea. Now, as you know, for the fault current calculation, it was done based on first 0, 1, 2 domain. Then it is shifted to ABC domain. Then we have applied that fault current to determine fault voltage for different bus, and then the line current. That means three different steps. Fault current determination, first step. Second step, bus voltage determination. Third step, the line current information during fault. It is for only one fault scenario,
Yes.
the bus balanced fault scenario. Now you can apply the similar concept for other fault as well. Okay, let's move to check the
So
other.
one small question, sir.
Yes.
Sir,
Follow.
when we found the V1, V2, V3, sir, why did we subtract it from 1, sir? 1 minus এটা কেন করেছিলাম?
1 minus actually pre-fault voltage or per unit voltage for the value of V1, it was initially 1. Okay.
Okay, sir. Okay, sir.
Initially pre-fault voltage during before fault it was 1, but during fault, due to the fault current effect, it was reduced from 1. Okay, and based on the intensity of fault current, the drop will be accordingly. That means it should be 1 for all the pre-fault voltage, or what we can say the initial voltage of those bus. Okay, without having any fault. But fault in bus 3, it is dropped from that reference value of 1 to certain value like 0.59 for first bus, likewise for other bus. And in that case, you can see here another interesting thing, that in which bus you have the most severe situation. The drop scenario, maximum drop scenario is in bus 3, right?
Yes.
Because it is the fault bus, and this bus will have the fault current effect more than other bus. That's why the drop for the bus 3 during fault V3F is smaller in terms of other bus voltage. Okay, from the reference value of 1. Now, as we have discussed this symmetrical fault scenario or balanced fault scenario, now we want to move for other fault which is unsymmetrical or unbalanced fault. Okay, so fault can be symmetrical because it is balanced fault, right? Balanced fault will have the symmetrical behavior, but it has magnitude issue, that it is the fault scenario. Okay. Second one is the another types of fault which we can consider single line to ground fault. That is actually unsymmetrical fault, right? Because it is not the symmetrical fault like earlier scenario. It is unsymmetrical fault.
No, sir.
Single line to ground,
Yes, sir.
that
Answer.
is unsymmetrical. The balanced fault is symmetrical fault. Though it is fault, it is symmetrical fault. It is something interesting, right? The balanced fault case.
Yes, sir.
You are saying
Yes, sir.
that it is fault, and by the same time, you are also mentioning that it is balanced. So you should not confused about that. Okay, balanced fault is there also, unbalanced fault, that unsymmetrical fault is other category. When you have single line to ground fault. So single line to ground fault, we have the issue of fault current like I3012 in terms of this matrix, this equation. Can you recall this equation? It was Z1 plus Z2 plus Z0 plus 3ZF, if you can recall that equation for single line to ground fault.
Sir, yes, sir. For the
Single line to ground fault
yes,
scenario.
sir.
So for this case, again, you have to use the matrix Z331. Okay, the positional value of Z33 matrix. Actually, what will be Z332?
Sir, from the negative sequence diagram.
Negative sequence matrix, right? Negative sequence matrix
Yes,
is already
the
mentioned.
matrix.
It is equal to the positive sequence matrix. So you can get the equal value like Z331. Okay. What about Z330? This will be different. Let's check Z330 from that matrix. This is Z0 matrix, and Z330 is this part, right? This is the Z33, which is 0.35.
Yes, sir. 3, 3. Yes.
Z33 in terms of 0. Okay, Z bus
Yes, sir.
0.
Yes, sir.
Here you can see Z bus 1 and Z bus 2 are same. That's why you can use the information of Z bus 1, which is 0.22 Z331 equals to Z332 as well. Okay.
Yes, sir.
So we
Sir,
have
in the first part, sir. In the first part, sir, our fault was what kind of fault? It was
three-phase fault, three-phase fault,
P
balance fault.
lines P line to ground fault.
Which one? Has three line to ground, right?
Yes.
Three line to ground or three-phase fault. Actually, three-phase fault is like that. Three line can be shorted to have that fault issue.
Yes, sir.
It might be ground, it might not be ground. So three-phase fault.
Yes, sir.
So single line to ground fault, it is only one line to ground fault. So we can find that, and ZF is already given, so we can find this information, right? So I30, I31, and I32, these all are same. Why these are all same? Can you recall why it is same for single line to ground fault scenario?
Because, sir, they all have the same
Why it is same?
potential I fault.
No, it is actually from the I calculation. If you can recall this I calculation, let's move
I forgot, sir.
there.
Yes.
I calculation. Here you can see from the I calculation. That means
Oh, okay. Yes. I
this
remember.
matrix will give
Yes,
you
sir.
that I1, I2, and I3. All will be same, right? That is for
Yes,
single
sir.
line to ground fault. From the I matrix equivalent, you have this relation.
Yes, sir.
So now move back to our main scenario. That's why you have this I1, I0, and I2 equal for single line to ground scenario especially. Okay, that will not be same for other case. This is only applicable for single line to ground fault case. And as you have all these information, this is the I30, I31 and I32, which all are same. Okay. And this is in terms of which domain? This information I3, 0, 1, 2 domain, right?
Sir,
Here you can
yes,
see
sir, 0, 1, 2 domain.
because impedances are 0, 1, 2 domain. So your current should be in also 0, 1, 2 domain. But our objective is to determine fault current in which domain? ABC domain, right?
ABC domains. Yes.
So ABC domain, you have to multiply A operator to get ABC domain information. Okay. So from
Yes.
I0, 1, 2 domain, this is all the 0, 1, 2 domain information. Because of single line to ground fault, all are same. So you have to put there and you can get I3 ABC after A matrix multiplication. Is it clear up to this point?
Yes, sir. Yes.
Okay. You have to be confident actually regarding that. Otherwise, it will be make problem some. So if it is clear,
Okay,
now
sir.
can you find voltage? First step is done already. Current calculation is done for current. Second step or second layer is determination of voltage, right? V1, V2, and V3F. Is it
Sir, can you repeat this one, sir, kindly again?
okay? First step was to determine the fault current in the concerned bus. Which bus has the fault effect?
Yes, sir.
Which bus has the fault? You have 3 bus, right?
Sir,
Which bus has
yes, sir.
bus 1, bus 2, or bus 3?
Bus 3, sir.
Only bus 3 has fault, right?
3, sir.
So bus 3 has fault.
Yes, sir.
And you have to determine the fault current for bus 3, which is there already in your hand. Now you have to find the voltage for all the bus. That means V1, V2, and V3. Okay. During fault.
Yes,
And
sir.
second layer. Fault current calculation is done already. Now you have to determine voltage. Let's see. Fault voltage in terms of 0, 1, 2 domain. Okay. V1,
Yes, sir.
V1, 0, 1, 2 domain during fault. Regarding this equation, can you recall this equation part? It is from EMF equation, right? The EMF.
Yes, sir. It's EA. Yes, sir.
EA and this part, actually only this positive sequence will have the voltage. That's why V1, 0 is there. That's why it is 1. Okay. And the other part you have 0 subtraction. It is the E equation. So
Yes,
V1, this part will be Z13 I3. This I3 is the fault current for 0, 1, 2. And there you have Z130, Z131, Z132. Okay. Z130, 131, and 132. You know, you have to use all the Z matrix information to put that information, right? From that Z bus matrix, you have to collect or extract that information. Z130, Z131, and Z132. Okay. So when you put that, you will get V1, 0, 1, 2. Is it okay? This part? দেখো সমস্যা থাকলে বলো।
Yes, sir.
আচ্ছা।
না, sir. ঠিক আছে, sir.
আচ্ছা, if it is okay, now can you find V2, 0, 1, 2 during fault? Write the equation like this. What will be the equation for V2, 0, 1, 2? Write that in your paper. So that
Sir, all the ones will be replaced by 2s.
Yes, all the ones should be replaced by 2 to get V2, 0, 1, 2, right? So let's check whether it match your concept or not. Is it okay? All the ones should be replaced by 2.
Yes, sir.
So it's fine. It satisfies your condition. Now if we want to find V3012 during F, the similar concept, right? All the 2 should be replaced by,
yes, sir.
it match your condition, right? It satisfy.
Yes, sir.
So by this way, what you have determined up to now, all the bus voltage V1, V2, V3 during fault F, right? But in which domain? 0,
Yes,
1,
sir.
2 domain. But our target is to find
Yes,
in
sir.
ABC domain, right? So what we have to do, we have
Yes,
to
sir.
use this information, 0, 1, 2 domain information by A operator multiplication to get ABC domain information, right?
Yes, sir.
Now let's check.
হ্যাঁ স্যার এটা তো নরমাল স্যার ইয়েস স্যার
এখন তো নরমালে চলে আসছো। এখন হচ্ছে V1 ABC will be V1 0, 1, 2 this information in terms of A operator, right? So that's the thing you have to do. First of all, you have to do that calculation in 0, 1, 2 domain, first step. Second step, you have to shift that information to ABC domain by A operator multiplication. Okay. For V2,
Okay.
you have to do the same, V3 as well. Okay. So you have done
ইয়েস স্যার
current calculation, fault current calculation in the bus, which is the fault bus 3. You have done all the bus voltage calculation, voltage during fault, right, in ABC domain. Now what is remaining?
ইয়েস স্যার
What is remaining now?
the fault current sir
Fault current is already done.
sorry না fault current না my bad
That is
Yes,
actually
sir.
line
Okay.
current. Line current during
line
fault.
current sir হ্যাঁ line current
Line current during fault, right?
yes
এখন তাহলে তুমি কি লাইন কারেন্ট বের করতে পারবা? How can you find line current now?
হ্যাঁ
V1
স্যার এর জন্য
V1 0, 1, 2 is in your hand. All the information are in your hand right now.
yes yes sir
So you can determine that 0, 1, 2 domain first. That is I21 0, 1, 2, right? V2
yes sir
V1 0 over Z1 to 0. This is the actually impedance information, okay, from the sequence diagram, that sequence
Yes.
impedance diagram. This is not the Z value, this is the impedance value, small z,
yes sir
and this is the V21 for V21. This is from positive sequence net circuit. So you will have all the information now in your hand, right? So you can find I21 in 0, 1, 2 domain.
yes sir
So likewise, you can find the other line current in 0, 1, 2 domain, 1, 3 and 2, 3 as well. 1, 3 and 2, 3, right? All are in now 0, 1, 2 domain. If it is in 0, 1, 2
Yes.
domain, your final target will be in ABC domain shift. That will you can do, right? Line
Yes.
current in ABC domain. So you know how to address or how to deal this issue. Okay. So can you summarize what will be the necessary thing you have to do if you are asked to determine fault calculation? The fault current calculation, first step, right? Second
yes sir
step
fault current হ্যাঁ
is the
Yes.
bus voltage calculation. Third step is the
Bus
line
voltage,
current
yes, sir.
calculation.
yes sir
These are the 3 layer. In that 3 layer, you have 2 sub layer. You have to do all the calculation at first in ABC 0, 1, 2 domain, because impedances are 0, 1, 2 domain. Then
Yes,
you
sir.
have to switch that information to its equivalent ABC domain. Okay. So that will be your target. That means that will be for any types of fault. Now, if it is okay, we can move for other fault, line to line fault. The process is same. You have to do the same job for different fault. We can just check whether that satisfy the situation or not. I30 For double line to ground fault, if you can recall, there will be some minus sign. Okay, minus sign between phase B and phase C, because phase B and phase C will be shorted, or it was shorted based on impedance ZF, based on fault impedance, right? And from that it was generated. Can you recall that? The line to line fault scenario, why it is negative,
Yes, sir.
or from where this negative comes? নেগেটিভটা আসলো কই থেকে?
স্যার মানে 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 নেগেটিভ সিকোয়েন্স
না, নেগেটিভ সিকোয়েন্স
যে
না,
ভ্যালুটা আসবে এটা হচ্ছে পজিটিভ। ওকে,
নেগেটিভ সিকোয়েন্স না। আচ্ছা, এটাকে আমি আবার ব্যাক করে আবার একটু রিভিউ করে আসি। এই নেগেটিভটা
হ্যাঁ স্যার।
it was from that for line to line fault we are discussing now.
Yes, sir.
Here it was the line to line fault scenario between bus phase B and phase C. You have the short impedance or fault impedance. So here you can see IB was
Oh, they are
minus
negative of
IB,
each other.
and why it is minus? Because IB plus IC is 0. Why IB plus
Yes.
IC is 0? Because they are in same combined path,
Yeah.
right? The direction of IB and direction of IC will make 0 effect for that short connection between
Yes.
line to line, and that's why your IB is equals to what? Or IB is equals to minus IC, right? Or IC equals minus IB. Is it okay? IC is equals to minus
Yes.
IB, and here it is IC information is put there, which is the information negative. That means IB is the positive sequence position or 1 position, and this is the 2 position, right?
Yes, sir.
So this is the reason actually for the negative, that IB plus IC is 0 and IC will be negative IB. That's why it is negative. Remember that. Okay. That's the position I31 and minus I32. It was the situation where we have. And another thing, the equation is already mentioned earlier lots of times. For single line to line fault, be careful about the equation. It is in this equation you don't have any zero sequence impedance, okay, for line to line fault. Only positive and negative will be there in terms of fault impedance. You don't have the presence of zero sequence impedance in this equation for line to line fault case. Okay.
Okay.
Remember that for line to line fault, though you may have calculated or you have the Z bus 0, but you don't need to use that information. It will be given, or it will be the redundant matrix for this case, line to line fault case. So sometimes the matrix will be given, but you have to be careful regarding handling those matrix. So first step that I have mentioned, that these are the impedance 0-1 domain. You will have the information of current in 0-1 domain, right? So these are 0-1 domain current. You can put those current to get ABC domain current in terms of bus voltage 3. Okay, for line to line fault case.
Yes, sir.
Second one is the fault voltage, bus voltage during fault, V1 012 in terms of fault. Okay, V2 012 in terms of fault. This is the during fault scenario. Another interesting thing you have to check here, the equation is 0. Okay, for line to line fault. Be careful about that. Single line to ground fault, you have some part, but for line to line fault, it is 0.
Yes, sir.
That is the only difference between these two concepts, line to line and double line. Line to line and single line to ground. Okay. The remaining things will be same. So when you have 0, 1, 2, you can apply for ABC. So we
Yes,
have done the solution or system, repeat similar. So we can then find the third step, which is the line current, I21 in terms of 0, 1, 2. And here also it is 0 for first term. Okay, be careful about line to line current equation. When you deal with line to line current, the first term will be 0 for all the scenario.
yes, sir.
Line fault current, okay. Then in ABC domain, the same process for all the line current in ABC domain. So we have done already 3 fault scenario, right? Balanced fault scenario, 3-phase fault, which is second one is single line to ground. Third scenario is line to line. Remaining fault is double line to ground, right? Double line to ground, the remaining
Yes,
fault. So double line to ground, it is also have some relation for I30, I32, I31 in terms of Z. Regarding double line to ground fault, you have to be careful about those current calculation. Okay, the current equation you have to actually practice more to remember or actually absorb this equation. Okay,
yes, sir.
how these equations are formed? Simple idea is to check Z0 plus 3ZF. Okay,
So we did this one last class, sir, or are we doing it today?
which one? This one?
Yes, sir. We did something like this last class, right,
Yes,
sir?
something like this in last class based on Thevenin concept. Now you are doing in Z-bus concept.
Yes, sir.
Same thing
Okay.
in other approach. Okay.
Okay, sir.
So these things are done in last class, but just to remember how you can actually absorb this equation. That's the trick. You have to consider Z0 plus 3ZF, okay, with Z2 parallel. That is some tricks to remember this formula. Okay.
Yes, sir.
Z0 3ZF with Z2 as parallel circuit and total configuration with Z1 in series. This is the explanation of this denominator part. And the upper part you can see here V30, which is 1 in general or P fault scenario. P fault per unit voltage will be 1 all the time, okay? Because it is on no fault situation or you don't have fault pre-fault scenario during pre-fault. Only fault will degrade the scenario from its normal or original initial value of 0. V30 means the voltage of bus 3 at initial condition or pre-fault condition. Okay. So you can find I32, I30. These equations are also there. You have to actually double line to ground fault. Be careful about that equation part. Otherwise, the concept will be same. Phase current, I3 ABC. These are already considered I3 0 2. These three things in terms of 0 1 2. And this is shifted to ABC. Okay. And for double line to ground fault, another additional thing you have to remember, total fault current, you cannot conclude here, I3 ABC. Okay. You have to make another additional step for total fault current in double line to ground scenario only. Okay. This is the additional equation or additional term for double line to ground. IB plus IC. Okay, remember that part. For double line to ground, you have to consider this part additional, beside the other fault. For other fault, you can conclude the solution up to this point. I3 ABC will be sufficient or enough. But for double line to ground, you have to consider I3B plus I3C, or based on fault bus, you have to consider that expression. Okay, this is I3B and this is I3C. So when you make that calculation, you will get total fault current during double line to ground fault. So other thing, the voltage equation will be similar to single line to ground. So you can use those formula which is already mentioned in single line to ground fault solution. But the value will be different for this case because the voltages are different. So bus voltage during fault in ABC domain, you can shift that, as well as the last stage is line current situation, right? Line current during fault, which is I12 and 012 domain. So this is all about today's discussion. So you can find line current in ABC as well from the 012 domain. So is there any question from your part? Otherwise we have, yes. If you have question, we can
no
share.
questions, sir.
Okay,
No
is it clear?
So I had one query, sir.
Query, yes?
Yes, sir, more or less, sir, yes. So we just have to practice it. Yes.
Practice korte hobe. I have given the document to your CR group. Some of you have already collected. Try to collect and practice. তোমার কোয়েরিটা বলো, তাড়াতাড়ি বলো, টাইম বেশি নাই।
Yes sir, হ্যাঁ স্যার, বেশি টাইম নেই স্যার, খুবই তাড়াতাড়ি বলছি স্যার। আপনি চলে রেকর্ডিং অফ করতে পারেন স্যার, অসুবিধা নেই। স্যার regarding our lab sir, yeah sir, regarding our lab sir, I think Haider sir yesterday or the day before sir sent us